Welcome to the Equations of Parallel and Perpendicular Lines podcast. This is podcast 1, and we're going to be looking at slope. All right, so a little anticipatory set to get us thinking about lines. How could we determine which of the following describes the line containing the points 2, 4, and 0, negative 2? Write down some ideas on how to determine the correct answer. Not what is the correct answer, but how could we figure it out? There's more than one correct answer. All right, so I want you to pause the tape and at the top of your notes, write down 1 or 2 ideas that you could use to figure out which is the correct answer. Okay, so I'll give you a second, just pause the tape, write them down, and then I'll go over the ones I think of. If there's some that I don't list and you put it on your paper, maybe you could share it with me, and then I could share it with the class. Okay? All right, welcome back. Let's see, what things did you come up with that you could use to figure out the equation of the line? Well, I know the first thing I have to do for a line is I would need to know what slope it is. So maybe I could find the slope. Oops, there he goes. The first time I try to write after I started recording, it never likes to write the very first time. There we go. Come on. So we could find the slope. Okay, so notice now that all of these lines don't have the same slope. As a matter of fact, only 2 of them have the same slope. So if we knew the slope, we would probably be able to either figure out our answer or maybe narrow it down. What else could we do? Well, maybe you want to go about it a different way. Maybe you want to graph. So you could graph the line. And you could graph the line by graphing the points. To graph the line, and you could see what your answer was. That would be an idea. Maybe you would just want to look at another part of the equation. Maybe instead of finding the slope, you're going to find the y-intercept. And actually, we're given the y-intercept in this particular problem. Okay? I'll point that out once I show you how to find the answer here. Some other ideas, maybe once you have the slope and the y-intercept, you might write the equation of the line. Using the slope and y-intercept. Right, so tomorrow in class you'll have to tell me if you came up with some other ideas. Those are 4 ideas that came up that I thought of first. Maybe you thought of something different. All right, so I'm not going to graph the points to graph the line on this particular problem because I don't have a coordinate plane up here. So I'm going to choose a different way. I think I'm going to find the slope. All right, so to find the slope, and that's actually what we're going to be working on. All right, I would take the difference in the y-coordinates, or the change in y, and divide that by the change in x. Right? That little triangle there doesn't mean triangle y and triangle x. And I have it on the next page when we get to slope. So I'll write it down on that page, but that means that's a delta. It's one of the Greek letters of the alphabet, and they use that to represent change. Okay, so when we see that in an equation next to a variable, we know that they're talking about a change in that variable. All right, so to find the slope, and I'm going to go over this a little bit later on, we could take the difference in the y-coordinates over the difference in the x-coordinates. That's how you find the slope, right? The change in y over the change in x. All right, so here, if I'm going to use these 2 points here, it doesn't really matter who's x1 and who's x2. I'll just call you x1, y1, and I'll call you x2, y2. I'm going to go right to left, or left to right here. And I'll call you x1, y1. Okay? So to find the slope, I would take the difference in those y-coordinates, 4 minus a negative 2, divided by 2 minus 0. And that would give me, those 2 negatives, that becomes a plus, right? So 6 divided by 2, right? Because 2 minus 0 would just be 2. And that's 3. Well, there's only one equation here. that has a slope of 3, and that's that one right there. The other ones have a slope of 1/3. Narrow down the choices to 2, and that's using the y-intercept because 0, -2 is the y-intercept. Okay, so the y-intercept is where the graph crosses the y-axis, and on the y-intercept, the x value is 0, and the y value is something else. Maybe it's 0 too. Maybe it's 0, 0, but it's something else. And so that would give us the point at -2. This, by the way, right there would be my y-intercept. But we're going to talk all about that in this upcoming lesson. So this was just a little intro to looking at some linear functions and just kind of figuring out some ways that we could represent a line. We're going to go over all the parts of this step by step by step in case you have any questions. Some of this might be a little bit review from Algebra 1, but some of this I'm guaranteeing is going to be new. Okay? All right, so let's get started with some notes. And this particular podcast is just going to deal with slope. I'm going to divide up my lesson into a couple parts, and I'm just going to cover one part at a time. And the first one's going to be slope. So this is right in your notes, already written down. What is slope? The slope of a line measures the steepness of the line. It's sometimes called rise over run. The slope of a line is the vertical change, rise, to the horizontal change, run. Slope is also a rate of change, which allows us to compare two different quantities that are changing. So slope provides an important way of visualizing a rate of change. Okay? So we're looking at a rate of change here. And we're going to really just be focusing on linear functions. So for us, that rate of change is going to be our slope. Right? Let's look at the formula. I kind of introduced it on that other page, but I have it over here fully in notes. You have this in your notes, and I even put a star next to it because it's very important. You'll need to be able to remember that formula. So the slope formula given 2 points. So if you're given 2 points, to figure out the slope, it's the rise over the run, or the change in y over the change in x, or delta y, which means change in y, over delta x, which means change in x. And to find that, you take the difference in your two y coordinates and the difference in your two x coordinates. Now those subscripts just indicate that there are two different points. It doesn't matter which one you call point 1 and which one you call point 2, as long as you were consistent throughout the problem. Notice in the last problem I was going to have that second point be point 2, and I decided I'd switch them up just because then I was subtracting 0 instead of subtracting from 0. In your notes, I'd like you to add this. There's plenty of space. It's the writing that's in there. All right, so just add delta y and delta x, and what that means, that it means change in y and change in x. So just the writing that I have there that's not part of your notes. Right? I'm not going to wait for you to write it down because guess what? You can pause me. I'm just going to continue on. All right, so example 1, find the slope of the straight line that passes through -5, 2 and 4, -7. All right, so we're going to find the difference in our y coordinates, that's the rise of the line, and over the difference in our x coordinates, that's the run of the line. All right, so I'm going to set this one up for you. This one is in your notes, so take notes along with me, or just pause me anytime you need to. All right, so I'm just going to go left to right all the way through these problems. All right, so this one will be y2, and this will be x1, y1. I'll just be consistent all the way through. All right, so it's going to be, our slope here is going to be 2 minus a -7 divided by -5 minus 4. 2 minus a -7, okay? I could simplify those double negatives. So if I'm subtracting something negative, I'm adding. So that would be 2 plus 7, which is going to be 9. And -5 divided by, -5 minus 4 is going to be -9. My tongue doesn't want to work today. 9 divided by -9, that reduces, that's -1. Oops, and my -1 is right off the page. I'm just going to slowly move these over. There you go. There we go. So write that in your notes. While you're writing that down, let's take a look at this line. All right, so here's a picture of our line. So notice that the slope of this line falls as we go from left to right. It has a negative slope. So y is decreasing as x is increasing. Right? And we can see from our graph, if you notice here, that our line is going, so between those 2 points, our line is going down 9 and to the right 9. And so that's how we got our slope. So that change in y was a negative 9, and the change in x was a positive 9. So that gives us a slope of negative 1. Okay. Let's look at another problem. All right, so example 2, find the slope of the straight line that passes through 1, 1 and 5, 1. Again, we're going to find the difference in the y coordinates over the difference in the x coordinates. And this will just be x2, y2, x1, y1. All right, so I have my slope is going to be 1 minus 1 divided by 1 minus 5. So 1 minus 1 is 0. And 1 minus 5 is a negative 4, but that simplifies to 0. If we divide 0 by any number, if you have nothing, you can't divide it into any groups. You still have nothing. So 0 is our slope here. While you're writing that down, let's take a look at our line here. So the slope of this line is, this is a horizontal line. It has 0 slope. Notice that y does not change as x increases. So notice we have the same y coordinates for both our x coordinates. Right? So this is a horizontal line. Let's graph of a horizontal line here. That's the end of my first part of my podcast. I am going to stop this podcast and do a new podcast. And we'll do these problems in class on Wednesday, okay? So we're going to stop. I'm going to stop the podcast, and I'm going to pick up with a new podcast. All right, so if you have any questions on slope, let me know, and I hope you enjoyed my podcast. Bye.